This is the June 2002 Algebra paper question number 2. When a solar cooker is pointing vertically upwards, the equation of its vertical cross-section is y equals x squared over 1.1, where the x-coordinate is the horizontal distance in meters from the bottom point of the solar cooker, and the y-coordinate is the vertical distance in meters above the bottom point of the solar cooker. On the grid opposite, draw the graph of y equals x squared over 1.1 for values of x between minus 0.7 and 0.7. Okay, so here's what the axes look like. Obviously, we need to go to table mode on the calculator. So that's mode table. Type in the f of x. So that's from here, y equals x squared. So x squared divided by 1.1. Remember, to get the x, you do alpha and then close bracket. Press equals. Now start, if we look up here, it says we've got to do values of x between minus 0.7 and 0.7. So I'm going to start at minus 0.7, end at 0.7, and step, well, it seems to sort of make sense to go up in 0.1s. Okay, so that gives me my table of values, and I need to plot the points on the graph on the grid. So the first point I've got to plot there is minus 0.7, 0.4454. Now if I look at the axes, I can plot minus 0.7, that's there, but I can't plot 0.4454 because my axes only go up in 0.01. So I've got 0.4 and then 0.41, 2, 3, 4, 5. So that's 0.45. But I can't plot any more accurate than that. So I'm going to have to round each of these values here to 2 decimal places, which means this first one is going to be 0.45, okay, because that 5 there rounds this value up to a 5. So I'm going to take my pen and I shall plot that point. So that was minus 0.7, so just checking the scale here, that's going to be halfway in between those two, so it's there, minus 0.7, and then it was 0.45, so 0.4, 0.41, 1.42, 4.3, 4.4, 4.5, so that takes me to that point there. And obviously I've got to remember when I'm doing this that I've got to plot the points accurate to within 1/2 a square. So I reckon that's got to be plotted exactly there. So I'll just put a little dot there, maybe turn that into a bit of a cross so that the examiners can kind of see I've plotted that in the right place. Okay, then from my table, remembering to scroll down to get all of the different values, I just then need to plot all the points on, which by the magic of technology, I can do like so. There we go, there's all my points. That one there in the wrong place. Okay, so I've got my points plotted now. It does say to draw the graph, which means that I need to join all these points up with a nice smooth curve that goes through all of the points. Again, it's got to be accurate to within 1/2 a square, so I don't want to be going wrong. So this is quite hard to do on the computer, but easier to do by hand with a nice sharp pencil. So I'm going to start at the origin and carefully kind of draw my way up. And yours is going to look much neater than this, because remember I'm just using a mouse here. So, and you might want to kind of just bring that up there like so. So when you do this, it's going to look much smoother, and obviously that is what the marks are for. The marks are for also making sure that you go through each of the points. And there we go, we've got a nice parabola shape there, as so. Okay, so that's part A done. Part B, calculate the 2 values of x where y equals 0.6. Okay, so to do that, I noticed first of all that it says calculate, which means I'm probably not supposed to read this off of the graph. Probably supposed to do this by calculation, i.e. by algebra. So I'll go back to see what the equation was. It was y equals x squared over 1.1. So let me write that down. Y equals x squared over 1.1. And now all I need to do is work out the values of x when y equals 0.6. So I'll put in y as 0.6. So 0.6 equals x squared over 1.1. Now, I just need to kind of solve this equation by removing all the different layers. So I've got to remove the outside layer first. So I've got to get rid of that 1.1 that's there on the bottom. So to do that, because it's being divided by 1.1, if I want to get rid of it, I have to times up. So I've got 0.6 times by 1.1 equals x squared. Okay, and then I need to get rid of the squaring, and the opposite of squaring is square rooting. So I'm going to do square root of whatever the answer to 0.6 times 1.1 is. I'll just type that in on my calculator, kind of exactly as it's written there, really. So go back into normal mode again, mode 1, and then I just want to do the square root of 0.6 times 1.1. Okay, so that's given me an answer there in kind of third form. To change back to decimals, just press this SD button, and I get 0.81. So x equals 0.81. But I've got to remember that whenever I take a square root, whenever I'm undoing the squaring by taking a square root, there's always two possible answers. Calculator gives me one, which is 0.81, but the other one is minus 0.81. Because minus 0.81 times by minus 0.81, the minuses cancel out, and we just get back to a positive again. So therefore, that is also a solution. So there's two solutions there. Got to make sure you write down both. Okay, next question, part C. On a solar cooker with a cross-section given by the equation y equals x squared over 4f, the centre of the cooking pot must be placed at 0f. Find the value of f for the equation given in part A. Well, the equation given in part A was just this one we've been working with, y equals x squared over 1.1. And I've got to find the value of f for the equation, which is kind of given up here. So what I want to do is kind of compare these two equations, this one here and this one here. And they're both, well, they obviously look the same, but the difference is what's on the bottom here. This one's got 4f on the bottom. This one's got a 1.1 on the bottom. So comparing those two together, then that's going to tell me that therefore 4f must equal 1.1. Okay. And so to find a value of f, I just need to do f equals 1.1 divided by 4, which I can type in onto my calculator, and if I do that, I get 0.275 as the value for f. Okay, second part of this question. Another solar cooker has the centre of its cooking pot 1.2 metres above the bottom of the cooker. What is the equation of the cross-section of this solar cooker? Okay, so if it's got a centre of its cooking pot 1.2 metres above the bottom of the cooker, that would be the value of f, okay? Because if we kind of look at what it says up here in the first part of this question, the centre of the cooking pot must be placed at 0f. So this time we got the centre of the cooking pot at 1.2 metres above the bottom of the cooker, and so therefore the 1.2 is the f, okay? So we just need to kind of substitute that value of 1.2 into this equation here, which we were given, and we just write down what the answer is. So we get y equals x squared over 4, and we've just decided that the value of f is 1.2, so 4 times 1.2. Okay, so if we just work out what that is, it's y equals x squared over 4.8. Okay, final part of this question, part D, says the graph on page 7 shows the graph of y against x for a part of another solar cooker with equation y equals x squared over 0.6. And it says draw on the graph on page 7 the graph of the inverse function. So here's the graph on page 7, looks like this. And to draw the inverse function, we've got to remember that the main thing to do is to reflect this curve here in the line y equals x. That's the important thing to remember about inverse functions. So therefore, the first thing that I need to do is draw the line y equals x in. So I'll just put a few dots at points on the line y equals x. Y equals x is where all the y values and the x values are the same. So at 0.2, 0.2 is going to be a point there. So I'll put a dot at that point. And then obviously 0.4, 0.4, and 0.6, 0.6. So that actually goes through the curve there. And obviously 0.8, 0.8 as well. And maybe 1, 1 as well we could put in finally there, which is there. Draw a nice straight line going through that. Just draw that in blue. Okay, so that's our line y equals x that we need to now reflect in. So basically what I need to do is to redraw this curve, but flip it over the line. And the key thing is that because it went through at the point 0.6, 0.6 here, when I reflect it, it's still got to go through at that point. Okay. So I'll probably want a few other points which I can kind of flip over. Obviously, 0, 0 is another point on the line, so it's got to go through that one as well. If I just kind of look at this point here, which is on the curve, which is 0.2, and then 0.0123. If I kind of reflect that point over to the line, that takes me to 0.2 that way, and then 0.03 that way. Okay, so I'll pop that point in there, and then we've got this point here, 0.4, and then that's 1, 2, 3 squares above 0.2, so going this way, 0.4, and then go to 0.2, and 1, 2, 3 squares there takes me to that point there. Okay. Right, I think I've got enough points there. I might want to probably put in the last point as well, which was this one. So that point there is at 0.7, and then 1 square above 0.8. So again, reflecting that over. So reflecting it was 0.7 here, which means it's now going to be 0.7 here. So 1, 2, 3, 4, 5 takes me to there. And then 0.8 and 1 square above takes me to there. Okay, so now I'll just draw as best I can on the computer a curve which looks the same as the original and goes through all the points that I've just identified. And I get something that looks like that. Okay, final bit of this question says, what is the equation of the inverse function? Okay, so the original function was y equals x squared over 0.6. That's the original curve. We want to get the equation of the inverse function. Now, if you think about it, what we just did over here was we reflected in the line y equals x. In other words, we just swapped all the x values and the y values. So that is what I need to do here. I basically just need to swap the x and the y over, because that's what I just did to draw the graph. So then the equation is x equals y squared over 0.6. And if you want to rearrange that to make y the subject, well, times up by that 0.6, so you get 0.6x equals y squared. And then to get rid of the squaring, you take a square root, so y equals the square root of 0.6x. And we're done.